Right, this is passage 6, and so I'm going to look at the passage, give it an overview, and decide on my strategy. Here we have 3 different graphs. We have one, this one here, that is different from the other 2. So that usually makes it that a wee bit more complicated. This one's going up, these are going down. It's not a huge introduction, but it's enough that it's got a chemical equation in it. So in this instance, I would probably read the introduction. If it's really simple and the graphs are alike and don't have a lot of information on them, and the introduction's, a couple of sentences or 3 sentences, I usually will just go straight into the questions. But this one's a wee bit more involved, so I'm going to read the introduction to sort of just get an idea of where I am. So when ibromobutane and sodium iodide and sodium are dissolved together in a solvent, acetone or acetone, it doesn't matter, acetone or, so the solvents are these 2. They react to form that, and sodium bromide, at least I can say that. And here's the chemical equation. Sodium bromide is not very soluble, so as it forms, it alone precipitates, and that looks like it's a kind of, that's a scientific term for it forms a solid, from the reaction solution. The reaction can be monitored by measuring the conductivity. Okay, so that's how they measure the precipitation of the sodium bromide. Got it. Of the reaction solution, because it's always a good thing to know, because sodium iodide is the only component that significantly contributes to the solution's conductivity. Okay, so I guess they're okay. All right, I've got a better idea. And then they did three studies to study the rate of the reaction of the sodium bromide becoming a solid. Got it. All right, that's as much as I'm going to read. I won't read the experiments. I'll use the questions to tell me when I have to do that. Okay, question 29. A difference between experiment 2 and 3 was that. Okay, first step, is not to do that. First step, we have to find experiment 2 and 3. So we have experiment, come over here, we have experiment 2, we have experiment 3, and then we have to find what was the difference between them. Okay, so I'm going to have to read both of them, it looks like. That's fine. Okay. Experiment 2. A capped test tube containing 800, whatever that is, of the acetone solution was mostly submerged in a water bath at 40 degrees. Another capped test tube containing 800 of this one, solution, a magnetic stir bar, and the conductivity probe, good grief, was mostly submerged in the bath. After 10 minutes, the tubes were uncapped, and that solution was added to the sodium iodide. The tube was capped and the solution was stirred in the bath. Conductivity readings were recorded at regular intervals. The trial was repeated twice. That's pretty involved. So experiment 3, we're looking for a difference. The trials of experiment 2 at 40 and at 20 were repeated. Okay, except, oh Lord, you know what, here's a tip. If you ever get a question like that, go to the experiment 3 last. Because, yeah, I should have done that. Here's a tip. Except, what is it? The solvent was different. Oh. So, a different solvent was used in experiment 2. Then, right, so it was A. And I could have saved myself a lot of time by knowing to look at experiment 3 first. Look at the second experiment, the note first. All right, so that's A. Okay, based on experiment 2, if a trial had been done in experiment 3 at 30 degrees, the conductivity at 6,000 sec would most likely have been. Right, experiment 2, if a trial had been done at 30 degrees. Experiment 2, it was done at 40 degrees. I've just scrolled all over it. So we have to find experiment 2, step 1, we've done that. If a trial had been done in experiment 3, so I have to find experiment 3 at 30 degrees. Okay, that's 2 is fine. Experiment 3, the conductivity. So experiment 2 was repeated. That's what it says. The trials of experiment 2 at 40 and 20 were repeated. Okay, so we know that experiment 3 just is experiment 2. So then we have 20 here and we have 40 here. So we'd expect 30 to be somewhere in the middle here and do that. That would be 30. And it's 6,000. We have to find that. That's it there. So we would expect it to be about 10, between less than 5 now, between 5 and 15. Yeah, it'd be between the 20 and the 40. So we'll go with G for that. In experiments 2 and 3, when the students were measuring the conductivity, they were directly monitoring the increase in the sodium iodide concentration, the decrease in the sodium iodide, increase in sodium bromide, decrease in sodium bromide in experiments 2 and 3. The conductivity... Oh, hang on, that was in the introduction. Remember, it said here, because, I'm glad I read it, because the sodium iodide is the only component that significantly contributes to the solution. So they're measuring sodium iodide. And in experiments 2 and 3, they were directly monitoring the conductivity is up here. And up, no, it's 2 and 3, sorry. And here. So the conductivity is going down, right? The conductivity is going down. So it would be a decrease in sodium iodide. Wow, that was kind of, if you hadn't read it, that would have been really quite a difficult question. All right, 32. What is the most likely reason? So that means it's probably not, it's not going to be in the passage. There's a hint. If it says most likely reason, it's not somewhere you can find it in the passage. It's going to ask about common sense or outside knowledge. Because if it was in the passage, it would say, what is the reason? So always bear that in mind. Always be on the lookout for most likely. So what is the most likely reason that in experiments 2 and 3, the test tubes were left in the bath for 10 minutes before their contents were mixed? All right, experiment 2, we read here, it says that after 10 minutes, the tubes were uncapped. So they were put in the water, and after 10 minutes, they were uncapped. And the solutions were mixed. All right, so let's see what the answers say. To increase the conductivity of the solution in each tube to a level that would allow the reaction to occur. I'm not sure about that. I don't know. I'll put a question mark there. G, to decrease the conductivity of the solution in each tube to a level that would allow the reaction to occur. I don't think that would be right, but I still don't know and it doesn't tell me. To ensure that the bath and the solution in each tube had reached room temperature? No, it's not anything to do with room temperature. The baths are 40 degrees and 20 degrees or something. J, to ensure that the solution in each tube had reached the temperature of the bath. There it is, right there. That's the only reason you would do it, because you're testing the conductivity at a temperature at 40 degrees or at 20 degrees. If you have a test tube and you have it full of some solution, you don't know what temperature it is at. It might be hotter than 40, it might be less than 40. So you'd put it in at 10 minutes, for 10 minutes, so that it can get to 40 degrees and you know you're testing it at the right temperature. So yeah, that's just a common sense one. Kind of tricky, but it's kind of a process of elimination. The other ones don't really make much sense. And I know that one does, so that's the one. I'm going for J. 33. During each of the trials and experiments 2 and 3, a white solid accumulated at the bottom of the test tube. What was this solid? All right, I think that's in paragraph 1 as well. Remember it said that sodium bromide, it says up here, we read it, it isn't soluble. So it precipitates, which means it forms a solid from the reaction solution. So that is D, NaBr, sodium bromide. All right, last question. This is a harder than normal passage. So, but again, with practice, you start to kind of get better at answering these, but If this one seems hard to you, then yeah, you're right. It's not the easiest passage I've ever seen. Right, suppose that at 40 degrees, 10 millimeters of 100 sodium iodide is mixed with the same amount of 300 of the acetone. So they're both the acetone one. Based on experiment 1, okay, so that's going to be step 1 is find experiment 1. The conductivity of the resulting solution will most likely, there's that little couple of words, most likely, which means it's probably not, you're not going to find it written on the graph. You're going to have to work it out. That's what most likely means. You're kind of guesstimating. All right, closest to which of the following? So we've got step 1 is experiment 1. Step 2 is find 40 degrees. Make sure that's what we're looking at, the right one. We're looking at, that's step 2. Make sure we know that. Step 3 is to find 100 mmol of that mixed with 300, so we have to find those two values. Oh, hang on, that's 3, sorry, and this is 4. And then work out 5 would be the answer. All right, let's do steps 1. Step 1 is we're looking at experiment 1, which means it would be figure 1 we're looking at. Suppose that at 40 degrees, it was at 40 degrees and then it was repeated once at 30 and once at 20. The results did not significantly differ, so it is at 40 degrees. So we can use this graph here. And if we mix 100, so where's that mmol? All right, so it's along the bottom here. So we know we've done step 1, we've found that. Step 2 is we know it's 40 degrees. 100 is here. That's step 3. Step 4 is find 300. And then we have to work out what's the most likely value. All right, so, and we're looking at, it's acetone. So at 100, it's about 8. And at 300, it's about 14. It's not quite as much. I think it's about 7. 5, so it's about 7, and this is about 14. So it would be somewhere between those two. So we look at the answers. We've got 11, 60. Okay, 16 is too big. 21, 30. So it's most likely 11, because it's between the values of 7 and 14. A hard passage. Hopefully you don't get one of those in the ACT, but if you do, just try and keep calm and do your steps and work it out as best as you can.